you stuck, you stupid chicken? Come on. Well, I'm going to call today's episode Temperature Fugit because, one, it's bloody cold outside, and it's been one of those days where everything that could go wrong did go wrong. Now, I've got a saying at work which is no good deed goes unpunished. So what we were trying to do here is just do a little bit of a good deed for one of our customers who just asked us, could we make him up a little simple interlock. He's got one of these selector switches on a piece of machinery which turns, you know, backwards and forwards and enables some operation on his equipment. And what our customer wants to be able to do is he wants to be able to lock this off in a certain position, which is in that direction. So we profiled cut a little stainless steel flap out for him, put it on a little axle, machine some blocks, and you lift this up and yeah, it almost fits. So you've got this basically a hinge cover plate, and we've got this little slot on here, and basically you can put a padlock through there. So you close this flap, if I can close it, which I can't close it at the moment. In fact, I'll take that switch off and show you it. Can I get the switch off? Got to admit, everything is a little bit tight on here. We're in a little bit of a rush for this. The customer was in a rush, so we basically just measured everything up quite crudely and sent it out for machining. And there's a stack up of errors. There's a few tolerance issues, and there's some machining issues, and yeah, oh God, sometimes you just have them days, don't you? I tell you what, let's sort that bugger out first. Ooh. Yeah, that was bound to happen. The head of this selector switch, it isn't quite lining up with the hole that we've milled out in this flap here. Well, it wasn't milled out, this is a laser cut sheet. It's really close, and well, I'm not actually sure where the problem has crept in actually. I'm not exactly sure. I had a quick look at the drawings and everything seems to line up on the drawings, but it's one of them situations where really it doesn't matter what's wrong. I don't have time to remachine it. I don't have time to do anything apart from really try to fix it. So what I think I'm going to have to do is well, I'm probably going to have to try and move some of these mounting holes over slightly. I'm kind of thinking what I might actually do is use this backing plate here. This has got all these holes marked into it, and in theory they're all good. So I'm thinking what we might do is we might use this plate here as a drilling jig, and maybe what we'll actually do is we'll move this selector switch. We'll move it over very slightly to the right by, well, we'll split the difference. We'll just move everything over to the right. So I'm wondering whether or not to start with a whole new plate. What will be easier, to mark out a whole new plate, or maybe to, I don't know, maybe to even weld a piece of metal back in here and just drill a hole. So these calipers are telling me that the gap's about 2.6 mil, but I think they're lying. I don't think I'm quite getting them in right. Side of the caliper, it's not quite getting into the hole. It's being obstructed by the switch body, I think. 2.5 mil. Not sure about that. So I'm just using some slip gauges there, and it looks like this gap is about 2.5 mil. So in theory we can we'll split the difference, I think, and we'll move this switch over. We'll move this key switch over to the right anyway, which should allow it to go through this flap. So what we need to do is we need to fill that hole in and drill a new hole. And what we'll do is then we'll use this back plate as a drill jig, and we will drill all these holes again in a new piece of metal, and in theory it should all line up and go together. Well, that's a theory anyway. Okay, I don't think that's a million miles out now. Cry freedom and let's slip the dogs of war. Well, you know, a precision job like this does call for a little bit of finesse. Unfortunately, we haven't got any. Ow, it's getting hot. That'll do. This stuff is kind of like black plate, so it's got like a layer of, I guess it's iron oxide mill scale. And the problem with mill scale is that, strangely enough, iron oxide melts at a much higher temperature than steel does. So if you're trying to weld something, it actually provides, you know, quite an effective barrier, and it stops it welding. Now, I'm not going to weld this in properly. I'm just going to use this as a drilling template, so it's not structural. So we just need to tack it in. And kind of wondering what is the easiest way to do it. My MIG welder is not set up with any wire in it at the moment because it goes rusty. I don't use it frequently enough. And my TIG welder, well, that hasn't been switched on for about 2 years, so I don't know how well that'll go. Alright, let's try the TIG welder because yeah, that's going to be just going to show you my level of incompetence at TIG welding. Yeah, that'll be a laugh. I'm going to quick weld my head. Well, you could tell I used to weld the bodies on Jaguars. Yeah, no. Now this welding that I've done, it's actually pretty appalling, and yeah, embarrassed to even show you. But I don't do a lot of TIG welding. In fact, that's the first time I've switched that machine on in 2 years. And the main reason I actually own a TIG welder is because, well, it kind of came into my hands at a price that I just couldn't afford to turn it down. To be honest, I thought it would be easier to use than it turned out to be. I suspect that my TIG welding career probably has lasted no more than about 2 hours in total. And yeah, it's not an easy thing to learn, TIG welding. That's all I can really say in my defence. It's not easy to do. You know, I just need more practice at it, and I probably really need you you know, probably somebody to take me in hand, as it were, somebody to show me the ropes, because everything I've learned from watching YouTube. But you know, for some things, there's no, you know, you just need to get a bit of tuition. And I did think maybe at some point I might go on one of these car body restoration courses where they do TIG welding, because it is a skill I would like to acquire. I can't really say more than that. I wish I could do it. So what I'm going to do is I'm going to assume that this disc that I've welded in is fairly well in the centre, and I think I'm going to set this up on the milling machine, and I'm just going to dial in an offset of 1.25 mil and re-drill it, because I think I'm just rubbish at measuring things. I've never been any good at it. I don't know why. I just shake, and my eyesight isn't great. I always get it wrong. So I think what we'll do is we'll let the dials on the milling machine help me get the right answer. Interesting to see that because we've welded it there, it's actually pulled in, it's actually distorted, it's dished, and that's always an interesting thing about welding. You always get distortion, and that's you know, that's the thing about a good welder. You know, people who weld a lot, they understand about distortion. I know it happens, but I don't really know how to prevent it. But lots to learn. Right, I'm going for my dinner. I will be back shortly. Do. And now we want to put 1.25 millimeters on our dial. There's 0.75, there's 1, there's 2.5. That's us. So this is only a template that we're making here for drilling the actual pilot holes and the actual real panel that we're going to bolt our flap to. It's just a matter of now choosing what drill size to use to drill these pilots, and I'm probably going to use, well, whatever the rest of them are. So it's either that one, that's 5, it's either 5 or is it 5.5? Right, okay, so feels like 5 mil that to me. And in theory, that's our template with the hole shifted for the switch by 1.25 millimeters. That's the bloody plan anyway. So here's our finished drilling template and a piece of scrap aluminium. So what we're going to do is we're just going to clamp the two together and drill all our holes, and then we will try and assemble that flap assembly, and I guess then we'll see if it actually does all fit together. So I guess it's time to place your bets. Now from memory, the hole for this switch will be 22.5 because that's what control panels use, and we're going to use one of these punches. But to enable us to punch it, what we've actually got to do is we've got to drill a hole for this bolt here. That's a slight annoyance because it's possible that the drill that's going to go through our sheet of aluminium plate here, it might wander a bit and make a bugger of our 1.5mm offset, but ah well, we'll have to suck it and see. Yeah, I'm actually a little bit worried. I think if we actually try to drill this with a 10 drill, it's just going to rip this aluminium apart. It's just going to pull its way through. So, although I don't really like them, I think I'll use a cone cutter. Problem using big drills on the sheet metal is they just grab. And the thing about these cone cutters is they don't grab. And I think they tend to stay fairly well centred. Which one's 10 on there? That one, just after the mark. Is that it? So as I said, this is a punch, and it's got basically a hole here, and it's got not a sharp edge, but it's got a 90-degree angle. It is slightly sharpened, and what happens is we tighten this bolt up, and it actually pulls this, well, pulls this, what do you call it? Pulls this punch. It's a punch, isn't it? It'll pull this punch into the female part. So we'll put the punch on this side, that on that side, tighten it up. Tell you what, just for you, I'm going to lean over the bench and take it from behind. Did that go? Felt like it might have done. And that gives us a very nice, crisp, clean hole without any mess around it. And in theory, our switch should be a good fit inside here, which is, it's a perfect fit because it's the right punch. So, like I say, it is the moment of truth. We've got to assemble the other parts and we'll see if it works. I've got to admit, I'm actually feeling quite apprehensive. Proper machinists, they work to like thousandths of an inch and stuff like that. Well, my tolerances tend to be 1 inch. I can just about hold a tolerance generally of 1 inch. I don't know how machinists do it. I mean, it isn't just the machines. They have a feel for all the measuring equipment that they use. On one of the other videos, I said, you know, people have a feel for things, or machinists do. I don't. I just don't have their level of skill because I'm not a machinist, of course, that's why. So I look at these holes I've drilled here, and there's only me that could actually drill triangular holes. So you can tell why I call this channel Allthegear and No Idea, because I've got all the gear, I just haven't got any idea how to use it. I think when we actually come to fit these in real life on the real panels, I think we'll drill these holes a little bit oversized, so we've got a little bit of a wriggle room. As I say, this whole job was just meant to be a quick little 10-minute job to help somebody out, and yeah, well, I'm afraid it didn't quite turn out that way. Okay, so we got it done. Just another 20 to do. Bye for now.